We tented this last night and put a small heater under the tent to bring the temperature up. We were using 2187 resin with a very long cure. And we wanted it to be hard enough this morning where we could show you this portion of the process. So we're going to open the bag up rather unceremoniously. There's nothing here to preserve of any real value. You find that this portion of the process generates a tremendous amount of garbage. You can save the perforated mylar, though. The perf will be totally reusable. The bleeder, of course, will not. I think we can safely get rid of the plastic here. We removed the vacuum last night after it had reached the point where the resin had gone beyond what we call the B stage. The B stage is that point that the resin can no longer be considered a liquid. It's a plastic, albeit it may be a soft plastic. It will no longer allow glass to expand to suck air back in. We're going to do a little trim here at the end, so leaving a little of this material behind won't hurt. Okay, now the bleeder, the perf, has done its job. Perf is also known as release, or release film, allowing the bleeder to debond from the surface. And it's still usable. Now we can pull the peel ply, which also removes more of the extra resin. We're shaping, JD. You can see the black line through the leading edge. We're going to take a small rotary saw and cut to the center and peel that off. You can clearly see through the laminate. You can see the dacron, your trim line for your rudder, the lines showing grain orientation. And it's a very, very lightweight and rigid part at this stage. We have one more laminate to do on the opposite side, another bagging operation, and your winglet will be finished. All right, we're going to trim this down, sand the glass right up against the foam. We'll give you a close-up of that in a moment. The major portion of the excess glass, followed by a sanding bar to really straighten it out. One of the rules of building, one of my rules of building, I should say, is that an airplane really looks good when everything that you see on the airplane looks as though it happened other than by accident.
This next section of tape is rather noisy, so we're showing you here a 3/8" Dremel saw attached to a Dremel tool. We're going to cut down the center line of the leading edge with this rather noisy beast. This can be done with a hacksaw blade. It can be done with a small handheld Dremel saw. This tool probably isn't the best to use because it generates a bit of heat and melts some foam away from the center line cut. Notice the smoke. Cameraman that can't focus. There we go. Now this is burning foam away slightly. Not of a great deal of concern, as you can backfill the depression caused by this burn down with a little bit of dry micro just prior to glassing the opposite side. After this cutting, we sand up from the cut, starting at about ½ inch or so, where we actually taper from that ½ inch point, sanding very little right to the center line of the leading edge, where we taper it to nearly nothing. You also sand 2 inches after the cut line in preparation for bonding the top skin wrapping around the leading edge. We had masking tape underneath this, and which makes a nice release. Now I'm going to spend a lot of time doing what I just described, sanding a taper on this. You'll have to excuse us leaving so much of this on here. But we thought that we were talking during this portion of the tape and that there were things that you needed to hear, so it got left on here. I start sanding at the center line, and I sand a little bit, look a lot. Sand a little bit, look a lot. Make sure that I sanded just next to nothing at the center line, tapering it to nothing, tapering it back up. If you do the trim with a razor blade prior to full cure, all that cutting is unnecessary, and the transition from the upper skin to the foam is much cleaner, much less foam damage. For those of you who are watching this tape, you can fast forward this now to the point where I'm just finishing this up, and we'll show you what it looks like.
Because of everything there, you'll fill this depression and this depression, this area, this cut line, you'll fill with dry micro, all the way down its length before glassing, just prior to glassing. We haven't sanded this surface yet, so you might notice that there's a little cleft from here to here. We did sand this section, but we'll sand the rest of this in the next section of the tape where we flip it over. Now that we're done with a good portion of the trimming, all the trimming at this stage, we're going to set up the next jigging operation, which will be an aluminum extrusion down the trailing edge and an aluminum extrusion down the leading edge. The one down the leading edge, we determine its position by taking a look at your sand down templates, and you measure, you find the talking number 3, and you find the same talking number on the opposing template. All I have to do is find that template, and you'll see the number 3 on it. By percentage, they're the same distance back from the leading edge. So we've placed a mark after the leading edge to number 3, and the same thing here. Our extrusion will be bonded in place lightly at the upper and lower end with a couple of blobs of Bondo. This one in this area, and then another one like so. We've taken a small quantity of Bondo out of the can and added the cream hardener to the surface. We have a little more there than we need. We're going to have a rather hot batch. For those of you who are not familiar with Bondo, the idea is the red pigment in the hardener allows you to mix the color of the material to a singular consistency, which will ensure complete cure. You can see on the back of the stick that you've got some gray and red material there, so we'll squish that out on both surfaces. Now this is a red mix. It's a very red mix, which means she's going to be hot. We want to move this along rather quickly. So. The Bondo we're applying does not go beyond the ½ inch or so of where the peel ply underneath is. When this extrusion gets popped off of here, we don't want to delaminate glass from foam. To be absolutely certain of this, we only put the extrusion in an area where it is glass to glass anyway, eliminating that possibility even further. I'm going to put a blob of Bondo at one end, a blob of Bondo at the other end of this extrusion, and we're going to place it on our marks. The vacuum bagging process is going to pull the extrusion firmly against the glass its entire length. So we don't need a Bondo at the entire length. We're going to be a little more forward of the trailing edge, and when they went to pop their extrusions off, they pulled glass from foam, and it showed up later on. We're, as I mentioned, bonding only in the area where it will be glass to glass. You can see the Dacron through the surface. You can tell where that glass to glass area will be. When we flip this over, we'll show you what that is supposed to look like. Okay, we've got the jigs in place. Trailing edge is bonded. Side of the leading edge looks straight. Trailing edge is absolutely dead straight. Now, because these two extrusions are not exactly on the same plane, before you flip it over, you determine that the two water lines are parallel with one another. This can be done with a pair of levels. And we've determined that this end of this template, I don't know if you can see this mark here where my finger is, but we've determined that this end is 1/8 of an inch higher than a parallel condition between these two bars. So when we flip this over, first of all, we check that the table is absolutely dead flat. And we've discovered that, well, this is where our 1/8 inch is. So we place an 1/8 inch shim between this extrusion and the table, creating a perfect parallel condition. Now we'll check this with a level on both ends to be absolutely sure that is the case. To 4, we're going to reinstall our jigs. We have a little better reference this time than we had last time. We have the exterior skin. of the undersurface. Well, I put an angle finder on here, and we're showing 1, 2, 3.5 degrees, 3.25 degrees. I'm going to repeat this on the opposite side. Now that we've determined that we have a parallel condition between one end and the other, we'll go ahead and bar sand down to the templates, just like we do on the opposite side. We're not going to show you the entire process. The same things apply. We'll sand down relatively close. First, I'm going to concentrate on the micro portions to get rid of this before I work on the rest of it. And due to the fact that we have an extrusion supporting the trailing edge and we have the extrusions bonded in place, we no longer... Now that we're done with the sanding process and the foam is right down to the template, now you see them, now you don't. We're going to continue from this portion. We're going to cut the jig foam trailing edge off and establish a glass-to-glass relationship. This can be done with a little cross-cut saw. I'll turn it around for you here and show you the trailing edge. For this particular process, I like using a regular small cross-cut saw. A large one wouldn't be a problem here either. And we very carefully cut the major portion of the foam off. I'll demonstrate how a short section of this can be done. Some of the glass that wrapped around the trailing edge during the vacuum bagging process is still here. This can be simplified greatly by having removed that prior to this stage. I missed that on the last thing. And what we're going to do now is I'm just going to show you in this one small area what the trailing edge should look like. You don't want to be too aggressive with a file. It'll end up digging in and removing too much material. We want this surface to flow smoothly into this area. Now underneath this foam, for the first half an inch, approximately first half an inch, is a layer of peel ply. I'm going to get underneath the peel ply in this area. First I have to find it. I don't know if Sergio's tape can see that. You have a close-up on that, Sergio? And we lift it up and peel it right on back. Run that the full length. Rather than pulling it like in that fashion its entire length, it's best to remove the larger portion of the foam first. I can take this opportunity to remove that section of the glass in that area. You'll repeat that process for the entire length of it, and I would suggest that you remove all the foam to this stage before you pull your peel ply. After you pull your peel ply, then you do a light transition in this area, angling about 30 degrees off of level. Okay, what I'd like Sergio to do here is bring the tape down to the leading edge so that you can see the tape I have here. What we want is we want a 2-inch lap from the upper surface to the lower surface. So we're going to mark that here. 2 inches isn't absolutely necessary, but we're going to give it, it's from the leading edge center here. We can go right up to the front of this leading edge extrusion. When this surface is microed and sanded, the last portion of the glass that laps will be tapered and feathered out. So we're going to make a mark all the way down the leading edge. It represents from 1 3/4 to 2 inches or so. Now we're going to sand that. It's been peel plied already, so you needn't use 36 grit to sand it. It'll sand fairly easily. You want to sand the epoxy off the surface so you can see very clearly that you're right up against the glass. This will improve your peel strength by 60%. The whole feel will change when you go through the resin and begin writing on the glass cloth itself. We'll complete that from here to the rest of it. We'll be back with you in a moment. What you can see here is that there's quite a bit of residual material left behind from the cutting process in the leading edge. We don't want this left behind, so we're going to grind it out of there. That little saw blade got pretty hot, and as it cut, it also melted away foam directly in the center line of the leading edge. Not to be concerned. We're going to backfill that with dry micro. Just before the line. Actually, this is done pretty simply. If you keep track of your cure, what you can do is when the resin has reached the B stage, it's still relatively soft, but will not suck air if you open the bag, is you can debag your vacuum bag and then use a razor blade to cut down the center line of your leading edge and remove the tape, thus avoiding the melting of the foam in this area. We're going to backfill that with dry micro just as we begin the laminate process, and it will receive glass micro slurry, and the whole works as one wet layer. Well, starting again, before we can go much further, we have to lay out our antennas. We'll bury a coaxial cable somewhere along the leading edge and lay out the foils on the upper surface. The foils are 20.3 inches long apiece and are set apart somewhere between 1/8 and 3/16 of an inch at their centers. The coaxial cable, RG58AU or RG58CU, emanates directly from the foil at 90 degrees. Comes to within about 1 inch of the leading edge, makes a sweep, a long curve, and then comes down. Now down at this portion of the wing, we're going to end up cutting this section off when we get ready to do our winglet installation. So before we get within 3 inches of this bottom section, we swing it forward and right to the center line leading edge. And then we run our cable from here down this direction. This all gets structural glass on the inside. We don't want the coaxial cable to interfere with that structural attachment. So we bring it, as I mentioned, forward and into the center line leading edge. We're going to take a Dremel with a router base, 1/8 inch in width, and route out this depression from here all the way to the foils. We'll need a slightly larger depression just ahead of the foils for the toroid beads. When you put the toroid beads on the end of your RG58, you'll be able to see what the depression needs to be, and we'll come back to that in a moment. What we've made here is a simple router base. The router base that we had for a Dremel tool didn't function anymore. So we poked a hole in a piece of blue PVC foam and allowed our router bit to stick through the bottom about 3/16 of an inch or so. We're going to follow this loosely from our tape area down the leading edge to the inboard section. At the moment I'm using my finger as a guide, so it should end up being very straight. Now we can do this freehand. Now what we'll do is we'll take our coaxial and we'll see if we can force it into the foam tightly. Didn't think it'd fit in there, did you? Well, it does, and it fits just below the surface. Take a straight edge and check it carefully. If you can zoom in there, Sergio, but it sits well below the surface. As I mentioned before, we're in the process of making the Radio Systems Technology dipole antenna. This is the shield on the exterior. This is the center conductor. This is its insulator. The insulator ends right here. The first toroid that they supply is back about its thickness from where the insulation ends. And then the distance between each toroid is about the thickness of a toroid. We used heat shrink over top of these three. If you have super glue handy, super glue is a much simpler and easier way to install. The heat shrink is not really necessary. We use it simply because we didn't have super glue. And the same criterion applies. About a toroid width between each toroid. 3 is the maximum you'll ever need on this antenna. The foam will be removed in this area to provide room for it. All this is going to be flush, and then the shield will solder to the bottom foil, and the center conductor will solder to the upper foil, and we'll go to that now. What we're doing at the moment is removing the material necessary to bury the toroid beads and the RG58 adjacent to the foil. Doesn't hurt to be a little over deep. We're going to backfill it with micro. We'll do a little trial fit right now. Make sure that we're long enough. Push down into the foam. Need to go deeper. The marks left behind will indicate to you what you need to do to make it fit correctly. Once you get it to fit, you don't have to put epoxy underneath it. I make this a close fit so that I don't have to fight the toroids rising up and putting a lump in my epoxy. I keep having and then reliving the old fears from a hand laid up wing that is not vacuum bagged When you vacuum bag, a lot of this is taken care of because the vacuum bagging process itself pulls all this stuff firmly into the core, usually leaving a depression, not a raised area. We're getting a very good fit of the RG58. Give you a good view of this. The foil will tie right to this corner. We'll snip a little more of this conductor off, and we'll snip a little more of this insulator off so that we get right to the corner of the foil. We'll solder it in place. The heat will melt the foam away slightly in that area. Where that occurs, you push the tape back down again to contact the foam, and you're going to backfill over top of the whole thing with dry micro. And now we've got our coaxial cable set up with our toroid beads. We're going to take the adhesive-backed copper foil, 1/2 inch wide. We've marked the length and the perimeter. Put it between the lines, rub it down, pull the backing. Set it right up over the surface. Cut it. 20.3 inches in length. Avoid handling the mastic back surface. Nothing really sticks to copper. If it's been tinned, some things stick to copper. What I'm going to do is take something smooth and rub it into the foam surface till it's approximately flush. Vacuum bagging takes care of a lot of sins. And we're going to rub it down, and we'll repeat that on the opposite side, and we'll be back to you in a moment. The coaxial buried, it's all below the surface. I've got my center conductor up above the surface, so I'm going to tin it real quick. I should have tinned it before I put it on here, but as long as it's not going to transfer heat to the foam, we're okay. Use the finest solder you can get so that you don't have to heat it much to get it to melt. We're wetting the lower conductor, the shield at this stage. Again, that should have been pre-tinned prior to the application. Now I go to the foil. I'm going to lift this up so you can see what I'm doing. I'm going to tin just the corners. Can you see that, Sergio?
Yes.
I just heard the foam burn away just slightly on that edge. Not a problem. We got tinning on both corners. I'm going to push the coaxial back into its depression. Nice thing about foam is it's got a springy quality. I push the conductor directly against the copper foil. I've got flow. Now I'm going to push the lower conductor against the foil. We have flow. It's melting down nicely into the foam. And I'm going to have Sergio unplug there and give you a close-up of how this looks. See, what we're illustrating here is that the coaxial is below the surface, and it begins to dive down into the depression as we get closer to the toroids. You can see that the toroids are well below the surface, all the way to the foil. And then I want to point out the solder adhesion to the edge of the tape. The tape, as it heated, melted into the foam, but we have good surface attachment. We're melted right in the surface, and all of this is below the surface. We backfill this with micro. We glass over top of it. So from this point onward, it's going to be a standard laminate. Now I want you to look aft a little bit to the rudder. We've done the rudder layout again. These lines are marked the same way they are on the opposite side. We'll do the same operation with P-apply in this area that we did on the opposite side. There are no other preparations necessary prior to the laminate. One last overview before you laminate this side. The preparation necessary prior to glassing is that your trailing edge glass-to-glass area, after you've pulled the peel ply, needs to be sanded with 80 grit to expose the glass filament itself, endeavoring not to bump or damage your foam. The layout of your rudder, the attachment of your foils, the soldering, the fitting of your coaxial, as well as what we showed you earlier, the sanding of 1.5 to 2 inches of your leading edge, as well as the tapering of your leading edge. Next application will be slurry and the 4 plies of glass. We're not going to show you the whole glassing operation like we did on the first shot. Most of what we're going to be doing is a repeat of the first process. There are some minor differences on this operation, most of which you've already seen in the preparation of antenna, trailing edge, and leading edge. On the leading edge, the one thing you haven't seen is the fact that we place the jig very close to the edge of the table so that we can get underneath it easily and apply resin to the surface that we have sanded. We've filled that leading edge area that I mentioned so that there are no voids left. We've filled over top of the coaxial, burying it, leaving nothing too high. Coaxial comes out the other end. We've got about 12 feet of coaxial hanging out of here. And we're going to wet that leading edge, and we're going to also wet the trailing edge, the glass-to-glass area at the back end of the canard that finishes out the structural triangulation of this particular structure. If this structure were much larger than this, it would require a spar down its center. But because it's relatively small in size, closing out at the leading edge and at the trailing edge helps provide sufficient stiffness to eliminate the need for a spar. It's also a relatively lightly loaded structure. We'll get back to when we begin to apply the first layer of glass. That'll be the last section that we show you in this tape, except for tomorrow morning we'll show you the application of microballoons along the trailing edge and the debagging of this particular part. Thank you. Before I go with the laminated glass, now we've got the peel ply down, I realize that this gives you an opportunity to make a mistake. As I have seen in the past, the peel ply in this area must not lap the glass-to-glass trailing edge section. You'll never get the peel ply out of that area, and it would always remain a weak area prone to delamination. So do not allow your tape to lap onto the glass-to-glass area. This is the last section of this tape. We're going to show you the leading edge lap. A simple way of obtaining that is to use your hand as a guide just above the leading edge center line, and with a felt tip marker, ride down the surface, leaving a mark. Folding underneath, making sure that it's going to go far enough to lap the area you want it to. We have that. We're going to cut it off real quick. More than likely, you're going to discover your own ways of doing these things, sometimes with more difficulty, sometimes with less difficulty. When you get to this end, be careful not to cut your coaxial. You're going to have to be cautious about that for quite some time to come in the future. We're going to wet this leading edge. The grain orientation at this point runs this way. We can wrap it around in that fashion. We've already wet the leading edges. Tuck it around the corner. No folds. Keep the grain orientation straight. The leading edge was placed, the jig here of the leading edge was placed just far enough back so as not to encumber your progress as you go to wet this out. A little light down here certainly wouldn't help, and a mild application of heat in these areas will help you wet them out. At this stage, it's just like the rest of the laminate. You have a glass-to-glass transition at the back end you're going to wet out, and its entire length, and we'll do a cut there. And the next time we speak to you, we'll be pulling the bag off. And now that we've removed the extrusions and trimmed around the perimeter, checked that everything is straight, we're going to do some minor filling. We've pulled the peel ply. We've removed the extrusions. We've trimmed around the entire perimeter of the part. We've checked that everything is straight the way it should be. We've also assessed minor indentations in the surfaces and irregularities. And we're going to sand this trailing edge depression in preparation for the trailing edge microfill. We'll be back with you in a moment. Now that we have the trailing edge sanded, we're going to mix up two shots of West Systems resin. There's one. There's two. Don't let anyone interrupt you while you're doing this. Now that you've got 2 shots of resin, we have one hardener. Mix well. We're going to mix this to a dry consistency. See the resin on the inside. The 205 hardener is pretty fast stuff, so you don't want to dally with this stuff. If you're mixing, make sure you have a well-ventilated room. Stuff likes to float. Now I want you to notice that I'm using this very, very white filler. It's very pleasing to the eye. We're going to be using a material that's made of phenolic, that's lighter and is easier to sand. I'll be providing you with ample examples of how to mix this material in our upcoming videotapes. I'm almost done with this. We're going to get a chance to show you an application. I won't just squeegee on a mass of this material and then just keep going on. I want to make sure that I've got it rubbed into the surface. It has well wetted the surface before I do the heavier amounts of fill. We do a sand out, getting right down to the fibers. I'm going to wet the edge just ahead of it a little bit so that I can feather this fill out later. Plus I have a minor depression in here. Now we'll finish up the rest of the fill. As you do this, do so in a manner that does not bring about capturing air in your micro. Overfill. Leave a little peak in the middle of it. After this cures, I'm going to come back with a Sureform, take the highs off, and then hit it with 36 followed by 80 grit. We'll be back with you to show that process in the next section of this tape. I suppose I should include this portion of the tape in the surfacing, but what the heck. I'm going to blow this off so you can see some of the porosity that occurred in the micro. We put this in our little hot box and heated it up. And as we heated it, small air bubbles underneath the skin formed and came up inside the micro. This will require, of course, subsequent fill. What I really want to show you here is how we get a smooth transition from this surface to the trailing edge. And I'll get our cameraman here to give us a close-up, and we'll be back with you in a moment after he's got his camera off the pedestal and down here close. Okay, what I wanted to show you here was the transition here where the glass goes to glass and how it's filled with microballoons. So it comes off from this surface tangent to this surface. When we're all done sanding this, if you've made the trailing edge a little thin, then you can take another straight edge, place it on the back and get rid of that razor sharp edge. You need it to be large enough radius where it will hold primer or paint without chipping off. I'd like you to take note of here is how the bag fits the extrusions. There's a pleat down the center so that when the vacuum was applied, no spanning occurred between the bag and the edge of the extrusion. I'm going to walk around here and show you what that looks like. This is the pleat I was referring to here. There's still a vacuum on this bag. You can see how there's no spanning across here. If that had been allowed to occur, the bag could have pulled on the extrusion and tweak the trailing edge out of its correct airfoil shape, which obviously is not what we want. I'm going to open this bag up and show you what this looks like. This is the quintessential expression of low tech. We had this heated overnight, tented in a cardboard box that got all the way to 130 degrees. 130 isn't as high as you need to go. Certainly doesn't hurt to go that high. Helps liquefy the resin and certainly gives you a well post-cured part. Painted white and not likely to ever reach 130 degrees. section of the bleeder is wrapped around the vacuum head so that it would not be occluded, covered by the plastic, thus preventing it from sucking a vacuum. This bleeder is the medium through which the vacuum is pulled and laps onto another section of the bleeder adjacent to the part. While we still have the jigs in place, we can pull the bleeder. If the release film has worked as it's supposed to, what you'll see is the individual small holes, clear perforated plastic over the glass-to-glass trailing edge. The background peel ply underneath it. This occurs wherever the bleeder didn't lap a laminate. It doesn't, I'm sorry, not the bleeder, but the perforated mylar. It doesn't hurt to make the mylar, or Tedlar in this case, an inch or so wider than the part around its entire perimeter so that you don't get this kind of perimeter bonding. Now this, I've been asked, why wouldn't you just put this material directly on top of the peel ply? What's this for? Well, without what is known as release film, you'd never be able to pull this off of the surface. The thicker the laminate is, which this would end up being a part of, the more difficult it is to peel off of a structure. And this makes it very simple, very easy to do. If you have this kind of bonding occurring around the edge, be cautious when you go to pull it off. You can pull your laminate right off your core. You can distinctly see the trim line for where the rudder gets cut out through the surfaces. You can also see the Dacron peel ply underneath, centered on either side of this. And the reason that I'm running this little piece of tape, something I forgot to do on the last tape, was to show you how to remove an extrusion from the laminate without damaging it. One of the reasons we go to such trouble to make sure that the extrusion is only attached to the glass-to-glass section of the trailing edge is to be sure that when we pop it off, that the peel loads that are applied to the laminate don't get transferred to the laminate attachment to the foam. Because that is where you will get a delamination. There are many long easies out there that have these little round divots. I shouldn't say divots, they look like blisters. And there are delaminations between the foam and the fiberglass. And it was just from such an occurrence that caused it. They put small dollops of Bondo on a piece of extrusion far enough forward of the trailing edge that when they popped it off, it delammed the foam. And we run the risk of that happening in this area as well. So we have to approach this very cautiously. If we run something between the extrusion and the glass, we can depress the glass into the foam with whatever device we are using to separate the two. Especially more critical at the upper end, due to the fact that in this area we only have 2 plies of fiberglass. This is already debonded.